38C the EngiCats.
Also known as Team Major Trouble.
This is our 2016 to 2017 video for the Create US Open Robotics Championship.
My name is Kate. I'm in 6th grade and this is my first year on the team. My jobs include Autodesk and PowerPoint.
Hi there, my name is Shreya. I'm in 8th grade and this is my second year in Major Trouble. Some of my jobs are documenting our season in our engineering notebook, coding, and I'm also the drive coach.
Hi, my name is Madison. I'm in 6th grade and this is my first year on the team. My jobs include Autodesk, design process, and scouting.
Hey, I'm Tori. I'm in 7th grade and this is my second year on the team. Some of my jobs include engineering notebook, scouting, and drive team.
Hi, my name is Annie. I'm in 8th grade and this is my second year on the team. Some of my jobs include working on our poster, taking pictures, and I'm also on the drive team.
Hey, I'm Emily. I'm in 7th grade and this is my first year on the team. I'm a programmer, scouter, and driver.
Hey, my name is Autumn. I'm in 7th grade and this is my first year on the team. Some of my jobs on the team include scouting, programming, and PowerPoint.
Hi there, my name's Addison. I'm in 7th grade and this is my second year on the team. Some of my jobs include Gantt chart, driving, and website.
Hi, I'm Julia and I'm in 6th grade and this is my first year on the team. Some of my jobs are Autodesk, marketing, and everyone on the team builds.
On our team, we have groups of 3. These groups of 3 focus on one job. They consist of a 6th, 7th, and 8th grader. The 8th grader acts as a mentor to the 6th and 7th graders who will be taking on this job next year.
Let's go meet our robot Charlie.
For our robot, we've chosen omnidirectional wheels instead of regular wheels because they help a robot move in any direction from any point in the field.
Our robot has an H-drive base. This helps us move left or right, which is called strafing, as well as forward and backward at the same time.
Charlie is made out of 2 different metals. On the bottom, it's aluminum and steel, because steel makes it more sturdy.
As you saw in our demonstration a few seconds ago, you can see that we have a lot of gears, and the gears help increase our torque.
For our end effector, we have pinchers. The pinchers can put more than 3 stars and a cube over the fence, and they can also knock stars off the fence.
One of the things we do for scouting is we have a sheet which we show to groups who we're aligned with in matches, and we make a plan for what we're going to do.
This we use during matches to look at teams and how they do, so maybe during a line selection we could select them or they could select us so we could do very well.
Another thing that we have is the design process. Here it is on the poster. This is how we track our progress and the major changes throughout the season. This is based on the engineering process.
The next thing we have up here is our Gantt chart. So our Gantt chart helps us keep track of what we're doing at each meeting. So we set out a plan of what we're going to do after each of our competitions so we accomplish everything that we want to before our next competition.
So we also have a SWOT chart. SWOT stands for Strengths, Weaknesses, Opportunities, and Threats, and this is the most recently updated version of our SWOT analysis chart. And we create these after every meet just to kind of get the idea of what our strengths and weaknesses are.
In order to simulate a judge's interview, we programmed a speaker. This speaker will ask us questions that a judge might ask us during a competition.
So before we use the speaker, what will we say some of our strengths and weaknesses are?
One of our main strengths is that we're a very well-rounded robot. This way we can adapt to partners quickly and easily during a match.
So some of our weaknesses, what would they be?
Some of our weaknesses is that we don't always land the stars and the cubes in the far zone.
Also, we currently cannot hang because of our size and weight.
How have you documented your robot this season?
So one thing that we have this year is an engineering notebook. So as you can see, we have a binder along with an actual engineering notebook inside. So in our binder, we have a lot of drawings of our robot. One of the things I'd like to point out is a sticky note diagram that we made. So we ordered all of our priorities for the year from 1, which is the most important, to number 5, which is the least important. We also have our code and a lot of graphs and charts in here. And so as you can see, we also have our actual engineering notebook. And so this is one of our pages. And as you can see, we have a summary page. We also have who attended the meeting, some tasks that we accomplished, a short summary at the bottom, pictures with captions, drawings, and also a little note at the bottom of who wrote the entry and who was there to witness the entry. And as you can see on the side, we also have tabs which correspond with the part of our robot based on the color. And so the numbers on the tabs correspond with the meetings in which we worked on a certain iteration of that part of our robot.
During meetings, we take notes on things that we do, things that we need to improve on, attendance, things like this. We then take these notes and make them into rough drafts. Later on, we work together to make these rough drafts into final drafts that then are put into the engineering notebook.
So using those final drafts that Tori just mentioned, we also have a website on which we have a blog. And on that blog, we upload those final drafts, which we'll talk about in a minute.
So as you can see behind us, we do have a poster that a lot of us have created here on the team. This shows all 3 pages of our Gantt chart, lots of team pictures with detailed descriptions, our one example of our scouting sheets, our first iteration of Autodesk because we do like to show improvement, some more pictures, our team summary, our entire design process with all the process steps and definitions, our 4 awards that we've won, and then also, as you can see right here, there is a picture of our QR code that leads to our team website, and you can take a mobile device and simply scan it, and it will bring you to our team's website.
As Annie just mentioned, we do have a team website. This includes facts about our team, robot, and other tidbits of information other teams might find helpful. We also have a blog that has all the engineering notebook entries that we have made for other teams to see how we're doing.
What was the hardest task for you to accomplish this year?
One of our hardest tasks was our autonomous code. This we have overcome through many a trial and error up to our most current version of it. At first, our robot would just drive up onto the field, and then it would just push our preload onto the other side. Then we came up with a jumper bar. This is full of jumper clips that each one runs a different code, which we can run with a jumper clip. That way, no matter what our lines can do, we have a working autonomous code.
So we soon realized, however, that with the jumper bar, we were only limited to a certain amount, and it took up a lot of space. So we decided it would be a better idea to create a autonomous selector using a potentiometer. So as you can see, we have the potentiometer underneath here, and it's connected to a sprocket. So on our potentiometer, certain ranges of values are associated with a certain autonomous code. So we'll turn the sprocket to whatever setting we want, which you can see by the markings here. Then we'll put our axle in to set it, and then we're ready for a match.
As seen from our autonomous code, we are constantly improving.
One main thing that we've improved is our robot's design. We started off with a windmill design that rotated clockwise and counterclockwise. The flaw with this was that it could only knock stars off the top of the fence. We then changed to a forklift design, like so, that could push stars and cubes under the fence, knock stars off the fence, and even throw items over. We then figured that pinchers would be much more quick and efficient, so we changed our robot to those.
So what would we say some aspects of community service you would have on the team?
One community service thing we did this year is we had an elementary school girl named Abby come in, and she was our apprentice, and she learned from us what to do when she's going to join the team next year.
So we also went to one of our local elementary schools, and we did this thing called Spark, and we talked to students about design process and stuff.
Another thing we have done recently in our community is we went to a local Barnes & Noble and talked to some kids about what it takes to be an engineer and what we do during robotics meetings.
One last thing, we have created a 3D model of our robot.
We made these 3D models using a program called Autodesk Inventor.
It includes all the same parts that our actual robot has.
This model shows Charlie when she has the forklift design.
And this model shows Charlie when she has the pincher design.
Thank you for your time.
We are all very appreciative of your consideration of Teammate of Trouble.
Thank you!